Hey Calc students, in this video I'm actually going to be watching different parts of a calculus help video and then explaining in my own words and using notes what the guy is trying to explain in the video. I think that it seems a little weird for me to videotape a video, but as you know, you're not allowed to pause calculus help videos, and you will be able to pause this video to take notes. And also, this is a really important concept, but I don't think he explains it in enough detail, so I'll be adding a little bit of detail to hopefully make it clear to you. So the video that I'm going to click on here is on chapter 2, finding the derivatives, and it's lesson 1, the difference quotient. So I'm going to pull it up. There's 3 parts to it. I'll let you watch each part and then I'll go over my notes. Here's the first part.
Before we get started, we need to answer one question. What is a derivative? Well, in calculus, the derivative is the slope of the tangent line to a graph. For instance, here's a graph, f of x, the point C that I've noted. The tangent to f at x equals c would look like this. In essence, a tangent line is just a line that touches the graph once at that point, sort of like a pencil resting there. Now, a function can have all sorts of different derivatives because, as you progress along a function, you can have all sorts of different tangent lines. Watch as the dot, which represents the x value, travels along the function, and how the tangent line changes as the dot moves. We need to figure out a way to determine exactly what the slope of that tangent line is, and we do that using something called the difference quotient.
So that is part 1. Now let me show you the notes that I took on that section. So the derivative is the slope of a tangent line to a graph. You've heard that word tangent in reference to the unit circle in trigonometry. Here though, I want you to remember that tangent just means that it's only touching the graph once in that place. So here we have an example that he showed in the problem, that you have a curve, and if you wanted to find the slope, for example, at this dot, we're basically saying what's the slope of the line that goes through that dot. It doesn't make sense to talk about the slope of a curve because a curve is always changing. The slope is constantly changing. So it makes more sense to think about the line that passes through that curve and think about the slope of that line. And then the other part of this video that's important is understanding the way that we write derivatives. So you've seen function notation probably since freshman year. F of x right here. If it's the derivative, it will have this little line up here, and we would call this actually f prime of x, or the derivative of f of x. So he didn't say that in the video, but I would write it down that this is pronounced f prime, like a prime number almost, f prime of x. Derivative is the slope of a tangent line to a graph. Now let's go ahead and watch the second part of the video.
In this section, I'm going to show you exactly where the difference quotient comes from. Here's a graph called f, with a point on it labeled x. My goal will be to find the slope of the tangent line to f at that point. First things first, the coordinates of this point are x, comma f of x. Now, here's how I get my formula. I'm going to move a small distance to the right of x, and I'm going to call this small distance delta x. It's mathematical language for the change in x. Therefore, this new location is the total distance of x plus delta x from the origin. And this new point has coordinates x plus delta x, comma, f of x plus delta x. Now, if I draw the line that connects these 2 points in red, it's called a secant line. It's not exactly like the tangent line we're looking for that I'm showing in blue, but at least it's a start. I'm going to go ahead and try to find the slope of this secant line. And to do that, I'll use the old formula from algebra, where slope is equal to y2 minus y1 divided by x2 minus x1. And I'll get the slope is f of x plus delta x minus f of x, all divided by the quantity x plus delta x minus x. And if I subtract those x's in the denominator, I get this. Now remember, this is the slope of the secant line, not the tangent line. So I'm not done yet. I need to find a line which is closer to the tangent line than this one.
Alright, so you might be a little bit lost after that video, not sure, but he uses a lot of math vocabulary that is really new to us. So let's go through it piece by piece. The first thing I said in the notes was Our goal is to find the slope of the curve at a certain point. So thinking about how they wrote this point, remember that this is the x-coordinate and the y-coordinate. To figure out the y-coordinate, you would plug x into that function. So we write as f of x as the y-coordinate. So we have a dot, we're trying to find the slope. But we know that to find a slope, you need 2 points. And so choose some other point. And I'm going to space it out so that it's a little bit easier to see. So we put this second point quite a far ways away. And so to find the slope using the 2 points, you connect them with a straight line. And so imagine a straight line going through these 2 points. So it would kind of go up above the curve there. That's called the secant line. So secant line, it's not really important vocabulary, but you should know that the secant line goes through at 2 points. The tangent line only touches it once. Well, what's with all this triangle business? Triangle is pronounced delta, and in math it means change in. So what we're basically saying is we're going to go along the x-axis for some distance, and let's call that the change in x. So we're adding some amount. We don't know how much. So this x-coordinate will be the original x-coordinate plus some amount. And to find the y value, you would plug that number into the function. So f of this new x value. Okay, then you have 2 points. To find the slope, we learned in Algebra 1 that it's the second y value minus the first y value divided by the second x value minus the first x value, or the change in y over the change in x. So here are my 2 points, point 1 in blue and point 2 in red. We have my first x value and my first y value, my second x value and my second y value. Writing it all together, it would be y2 minus y1 divided by x2 minus x1. Is there any simplifying that we can do on this? Only a little bit. This x will cancel with this negative x, and we'll be left with just the change in x, or delta x, in the denominator of this fraction. And that's it for part 2. So now let's watch the last part of the video.
Let's look at that graph again. What happens if I were to make delta x smaller? In other words, my second point will be closer to x than it was before. Now, if I draw the secant line connecting my original point to my new point, which is slightly closer, I will get a secant line which looks more like the tangent line than the previous one did. It's getting closer to it. In fact, the smaller delta x is, the closer this secant line will be to the tangent line. Watch on this animation as the delta x goes from really big to really small. The red secant line comes closer and closer to the blue tangent line. We want delta x to be as small as possible. So therefore I need to make a small adjustment to my secant slope. Remember, that was f of x plus delta x minus f of x all over delta x. But we want to specifically say that that delta x needs to be as small as possible so those lines basically overlap. And to do that, we'll use a limit. All we do is add in the limit as delta x goes to 0. In other words, I want delta x to become so small it's almost 0. It can't be 0 because then I would have 0 in the denominator of the fraction. That's why I have to use a limit. And I say, get that delta x as small as possible. This is the difference quotient. It is the mathematical definition of the derivative.
So that is the end of the 3-part video. Let me just go over a few points from that. The first key point was we needed 2 points to find the slope. It's better if the 2 points are as close to each other as possible. And the closer they get, the more accurate our slope estimate will be. The closer my 2 points get, the more accurate my slope estimate will be. So we don't want them to be far apart like this. We want to move them closer and closer and closer. In other words, we want this little amount, this delta x, or this change in x, we want to get it as small as possible. So basically you have 2 points that are almost the exact same point. They're so close. Now, we had it written on the previous page that this is how we would find the slope, or the derivative. And now we're saying that we want this amount, this delta x, to be so small that it's approaching 0. As he said in the video, we can't just have it be equal to 0. or the function would be undefined, the fraction would be undefined. But we can have it approach 0, so getting closer and closer and closer. So I'll stop, but remember that you can go back in this video. Your notes should be really complete for this part of calculus. You need to have a really good understanding of why this function is written the way that it is. And that's it. Thanks for watching.